Okay, in today's video, what I want to talk about is something very, very important. It's the debris evidence. Uh, in, to be specific, I'm talking about the debris that was found in Africa, which is either certain to be from MH370 or believed to be from MH370. And what I'm showing you here is a map that, let me see if I can bring this up a little better for you. This is a map that is up on the internet, and I'll give you the link in just a second. But if you look at this map, you can see where all the debris pieces so far have been found in Africa. And this map is exceptional because let me just put this up here for a sec. Okay, let me bring this down here for a sec. What is great about this map is it's an interactive map on Google. So you can click on a piece and you can see a picture of the piece and get information on it. Now, some of the pictures aren't there on some of the pieces. Let me see. Yeah, some of them are missing photos, but some of them have the photos anyway. So you can see what the piece looks like, get information on where it was found, time of discovery, etc., who found it, everything. So this is an excellent map to use when analyzing the debris in. Let me just see if I can zoom out here a bit. Yeah, here we go. Yeah, so this is a really excellent map for analyzing the debris and learning about all the debris pieces that were found in Africa for MH370. And so I put up a link here. Now let me bring this up again. Okay. So now here are like 5 of the pieces that have been confirmed to be from MH370. You have the flap round here. You have part of the engine cowling, Rolls-Royce engine logo. This piece is called the nose step piece, which was found by Blaine Gibson. And the rest of the pieces fall into the category of most likely from the plane or could be from the plane, but or some would say very likely from the aircraft. But these are the confirmed pieces. And so they have been found in these areas here. And as you can see, uh, the green check marks are the ones that are confirmed. Okay, so let me bring this up again now. Okay, so now we'll go to the next slide here. Yeah, now here's Blaine Gibson, who found quite a few of these pieces. Now, I some people have accused him of being a Russian spy who planted debris. To me, that is absolutely ludicrous. Blaine is a decent guy who, on his own dime, got off his ass and tried to find answers for us about what happened to this plane. And he did. If it wasn't for him, half the pieces that we have found were because of him and not because of anything suspicious, because simply he was in the right place at the right time looking for pieces. And that's why he found so many. That's it. He was in the right place at the right time. He was there. He had the resources to go there and look, and he found answers. This is something, we should be appreciative of his effort. And I also think that the reports that he did on the Maldives and on Kate T's sighting were excellent and were extremely helpful in putting together my theory and my investigation. So I think Blaine's a hero here, and the pieces he found are definitely from the aircraft. So that's it. Now, some people say if the debris was planted, and the problem with that is if you look at the flap around piece, the barnacles on it, There's some samples there that barnacles that were the French BEA have in their lab that tells them that the flaperon was in the water for at least 14 months. So if someone planted debris, they would have had to have done it in the first 2 months because that piece was in the water for at least 14 months. So we know from that piece, very unlikely anyone did any planting of evidence. It's ridiculous, and it's just a ludicrous theory that some journalist put forward in order to fit his theory. But it's not true. The debris in Africa, this debris here that we see in Africa, drifted naturally from somewhere in the Indian Ocean where it was ditched. No one planted debris. No one's a Russian spy. Nothing like that happened, in my opinion. So now, if we take this approach to the debris evidence and say no one planted it, no one's a spy, whatever, it just drifted there naturally from where it crashed, then somewhere in here, in this Indian Ocean here, is where the wreckage of MH370 is. It's somewhere either down here near the Maldives, Diego Garcia, whatever. It's somewhere in the Indian Ocean in this area. Okay? We can say that with relative certainty, given the fact that we have so many pieces of debris of the plane found. It's pretty certain the plane is somewhere in the ocean somewhere. And if people have a hard time accepting that, well, it's time to start accepting that. But there's more to the story than meets the eye. So, and now let me go back here. Now, when the flaperon piece was discovered, that was the first piece that was discovered right here on Reunion Island. It was in July of 2015. They discovered this flaperon piece, and I'll bring that up in a second here. I'll show you the flaperon piece, this piece here. They discovered it the 29th of July, 2015 on Reunion Island, right here. Saint Denis La Réunion. Okay, so based on the discovery of that debris, several oceanographers and companies did reverse drift studies on this particular one piece of debris. And what they found was very revealing. Now, in this study done by the company ICMAT, uh, the origin point is, of course, where the debris piece was found. And what these blue dots represent are all the probable locations of origins of where the piece could have originated from on the 8th of March. So they go back 16 months in reverse drift analysis, and it basically gives them this ambiguous result. It's somewhere up in, could have originated somewhere in these blue spots. That's what it tells us. But interestingly, it tells us there's no way this piece came from anywhere near the seventh arc. That's what that study tells us. The flaperon piece came from nowhere near this arc. That's what this study is telling us. Now, the next study was done by Geomar, and they did a similar study. This is the origin of the reverse drift study, and this is the results that they got. Again, not very specific, but it shows you it doesn't look like it came from anywhere down here where they were looking. In fact, it only shows a bit of probability at the northern part of the that seventh arc in this area. So that was another reverse drift study done on the flaperon, same piece. This is another graphic by Geomar. This shows it a little more clearly with the arc, but you can see very likely the piece came from somewhere over here than down here. Clear as day. There's another study done by Météo France, and again, we see the probability is in this area here. This is where the debris is coming from, not from down here. From up, that's where the flaperon they believe is coming from. That's what the historical data that they're looking at. And now this data that they look at is based on NOAA buoy data over the last maybe 30, 40 years of historical data that they track these buoys in the water, and they're able to get the GPS tracking location, and they build up a database from that information. So that's how they're able to do these reverse drift analysis by using that data. So this here shows you the probability places where this piece would have came from, nowhere near where they were looking. That's another study I showed you. Now here's another one by Eric Van Zeebel, who's an oceanographer who I'm going to talk about in a second. He did his own reverse drift study on that flaperon piece, and again, it doesn't show much probability that it came from where they were looking down here. It showed it coming from this area over up here. So all four of these studies seem to contradict the SIO search area. This area here where they were looking. Now, the ATSB did their own study on this. They did their own drift analysis, and they used a bunch of dummy flaperons with trackers and dumped them in the water in these various areas and tracked them for, I think, about 8 months. And this is the results that they got after 8 months. All of the debris started showing up after 8 months, either in Australia or in Africa, and neither are consistent with the time and or locations at which MH3 debris was discovered, therefore reducing the likelihood of debris originating from these locations. So it is very unlikely that the debris piece, at least the flaperon we can say from the reverse drift models, did not originate from anywhere down here. And it's very unlikely from the own Cicero study done for the ATSB that any chance of MH370 crashing down here is extremely unlikely based on drift modeling and ocean science. Extremely unlikely. So now I want to show you what I did. This is my a reverse drift study I did based on not just one piece of debris evidence, but based on 26 pieces of debris evidence. I'll show you how I did that in a moment, but I want to show you where I got the information from. Now, when I did this study, this site here, adrift.org.au, was the site that I was using. It is now called this site, plasticadrift.org. It's basically the same site, just a different website now, website name. Now, in this website, it looks a bit like a kid's website because you have to place a rubber ducky. If you place the rubber ducky, it will give you, in this case, a forward drift analysis. There you go. And so it shows you where, in this case, shows you where plastic ends up. So if you dump a plastic bottle in the ocean here, over time, it's going to end up over here. And this data, it looks, you look at this website and you think it's, well, how accurate is the data? Well, here's the thing. This website was created by this this oceanographer, Eric Van Zeebel. He's the one who did that reverse drift study I showed you earlier. And he is behind this website. And he created this website in order to better understand how plastics drift in the ocean, and for environmental purposes and for scientific research. And the data that he uses in this website is from the NOAA buoy data database. So it's all historical data from various NOAA Global Drifting Buoy Program. So going back to here now. Let me go back to the website here. So the information that you can get from this website is very useful. Now you can set it up to either do a forward drift or a backwards drift. Now for the study that I did backward drift. And what I did was I basically select a point on the map and then I run the backward drift. And then once the backward drift is done, I can download the data from the website into an Excel spreadsheet. And you can do this for any location down here where there's a debris piece. You can locate the duct precisely. I can do it with actually locating it precisely by using changing the coordinates in the web link at the time. So I was able to just specify the coordinates, run the reverse drift model, and then download the information. And I would download it into an Excel spreadsheet like this. This is the spreadsheet I used, and this is the data that was downloaded from the website. So what I do at this point for now let me go back here and explain this a bit better. Come on, okay. What am I doing wrong here? This one, okay. Yeah, so each piece, depending on the time of discovery, will have a different drift time. And the data that I'm using goes in increments of 2 months. So I can go 14 months, 16 months, 18 months, 20 months for the data for drift time. So that's as accurate as I can be with this data. But it's good enough to give me decent results. Now, this is my reverse drift model for the flap around. And I don't have it overlay on a map, but this is the longitude and latitude, latitude, longitude shown on the map. Reunion Island is about here, and the seventh arc goes up something like this. So this reverse drift model shows that there is some probability that the flop around could have originated from the seventh arc, but from down here where they were searching, it shows no possibility, just like the other four reverse drift models. I'll bring up, let me bring up the other one there. I'll go back here. Here's a comparison between Eric von Siebel's reverse drift model that he did and mine. So they're not the same, but there are similarities. And if you look at the Météo France, same basic pattern I see in them. You know, the debris is originating more towards Indonesia in the northern part of the Indian Ocean rather than the south. That's very clear from all these reverse drift models I'm looking at on the flaperon. Okay, so what I did is on every piece that was found, I documented. In this study, I did 26 pieces at the time. This was in 2017, I believe. And I documented 26 pieces. And this is the drift time by 20 months and the coordinates that I used to create the data. And the data was all stored in this Excel file. And once I got the data in the file, I created what's known as a transit matrix, which is shows all the probabilities where the piece could have originated from in this matrix that you see here. Now, why am I doing that? Because at the end, what I do is I add up all the matrices and I get a composite result. And that's what I want to show you in a second later on. But first off, let me just go back here and I'll keep, I don't know what I'm doing on time here. Okay, I think I'm okay for now. But so now, let me just do something right here, right now, so that I can see what I'm doing here. Okay, I know where I am on time. That's very important. Okay, so this analysis, I did 26 reverse matrix or matrices on each of these debris pieces. Now, this is the no step for. Let me go back here. This piece here was found in December 2015, and it was found in Mozambique, and it's been confirmed to be from MH370. And what's interesting about my uh, reverse transit matrix for this piece, it shows no probability that it could have originated from anywhere along the seventh arc. 0% probability. So that basically this matrix here eliminates the seventh arc as a potential location from where all these debris pieces could have originated from. So that I found interesting. Now I did modeling for every piece here. Here's another piece, the Rolls-Royce engine piece. This piece was found in South Africa in March of 2016, and I gave it a 20-month drift time. And when I do a 20-month drift time on that piece, it does not show any probability of originating from the seventh arc. The seventh arc starts around here at the 110 longitude and goes down to about 30, 35, so somewhere like this. It shows no probability that this piece could have possibly originated from that search area where you're looking or anywhere near the seventh arc. So they'll have two pieces there that show 0% possibility of originating from the seventh arc or from the southern Indian Ocean. And a lot of these pieces, as you can see, seem to be further north of where the search area was. And so, anyways, I did this for 26 pieces of debris. I'm not going to go into every one and show you. You can go to the website and review them. But what I want to get to is the results of this. So basically, if you understand what I did, is I just downloaded data from this website here, got the reverse drift data, loaded into an Excel sheet, and created these transit matrix for each piece over the time period of the drift, of their drift time. So I did this individually, piece one by one. So finally, I get down to the results here. Now, here are the results. The first interesting result is that several of these reverse drift models, items 2, 3, 4, 6, 7, 9, show 0% probability of originating from the current ATSB seabed search area. Therefore, this cannot possibly be the location of where MH370 crashed. That's this location down here. The reverse drift model for item 4, I would also say item 2 as well, shows 0% probability that it could have originated from anywhere near the seventh arc in a 20-month drift time period. If the drift time is closer to 21 months, there is only a low probability it could have originated from the seventh arc above 27. So even up here, it shows very low. Even if one piece does not match up here, then that's not where the plane crashed. So it's clear to me this seventh arc is invalid. This is not where MH370 crashed, based on this data. Most of the reverse drift models show a greater probability of originating closer to the equator than anywhere near the seventh arc. In fact, of the reverse drift models, only 3 show a low probability of originating from the seventh arc at all. In fact, most of the reverse drift models show a low. Most of them show low probability of originating from this area, and some show no probability at all. So that cannot be where the plane crashed. And most of the models show that they originated up here. Now the question is, was it the Maldives or was it Sumatra or the Andaman Sea in this area? This is where most of the models are indicating where the debris is coming from. Now, When I add up all the models, this is what I get. This is the total 26 matrices completely added up. And you see we get a high probability over here in the Maldives, but we get an even greater probability over here. And I'll show you why. I'll tell you why in a sec that why this area is the critical area. The graphic below is a composite reverse drift model containing all the drift data of all the reverse drift models in this study and shows all the origin points of all debris items. It should be noted that some origin points which have a very low weight become so small that they are simply not visible in this graphic. The area which best satisfies and is consistent with all the reverse drift models and shows the highest concentration of high probability origin points is shown in the red box. This box here, this is where all the pieces in this study show some degree of probability of originating from. And when you look at the probability in this area, it's the highest concentration throughout the model. So this is the most likely area in the model where all these pieces came from. This area is close to the equator near Indonesia and covers an area between longitude 80 east and 95 east and between latitude 8 north and 7 south. Areas outside this red box show high probability are not consistent with all the reverse drift models. That's this area here. Some of them show high probability, but there are some pieces that did not show any possibility of originating in near the Maldives. So I can exclude the Maldives and the seventh arc as being points of origin. Interesting, Diego Garcia is still common to all 26, but there's more probability in this area than in the area of Diego Garcia. And it's not surprising since Diego Garcia is closer to Africa than Sumatra and it's in the past. So it's normal that I would expect this to be common. If the plane did crash in this area, it would be reasonable to assume that there would be commonality between these two locations here. But my analysis shows very clearly that the debris in Africa is originating from somewhere within that red box. That's where the haystack is in the Indian Ocean. This is where it is. Of all the information that reverse drift models and adding up all the reverse transit matrix and doing a statistical analysis looking at individual pieces, this area here appears to be the most likely area in the entire Indian Ocean of where the debris in Africa related to MH370 was originating from. And inside this red box is this yellow dot, and this is where debris was captured in satellite imagery. Let me bring this up here right now. Go back here. Yeah, this is where the debris is pointing to, this area here. This is where the reverse drift modeling is indicating this area here is where the haystack is. That's about the best we can do with this data. It'll never tell us precisely where the aircraft is, but it certainly can be used, is good enough to tell us where the highest probability area where it should be. And that's clearly from my study and from the analysis that I've done, it shows it's in this area here. This is the area where MH370 crashed. That's where the wreckage is. That's where the satellite imagery was taken, and that's where the woman Raja on an airplane up here, just a little north of this area, saw it being ditched. So it's very likely, and I'm virtually certain of my opinion here. As certain as I can be, based on all the analysis I've done on the previous data, the witness data, imagery data, Inmarsat data, radar data, and this data here, which is completely independent of all that data, this result tells me I'm right. Okay, now what I want to talk about is the barnacles. This is a study that was done on the barnacles that were attached to the flaperon piece when it showed up on Reunion Island. The piece, let me go back here. I'll bring it back up. I just want to show you. Yeah, this piece here was covered with barnacles when it showed up on Reunion Island, and the samples were kept in a lab. And the French BEA, who investigate uh, the flaperon, have samples of these barnacles. Now, let me bring this up. Now, there's been a couple of studies done on barnacles. One was done by uh, this group here, Digital Commons University of South Florida. They did a study on the barnacle, and there's a lot of scientific data in here, which is techno mumbo jumbo. But if I can find it, well, basically, I'll just show you the graphic I want to show you here from this study. Yeah, in this study is this graphic here, which shows the probable locations of where the flaperon would have drifted through, probable location of waters where the flaperon would have drifted to on its way to Reunion Island over here. And so this study shows, previous study shows that more likely it originated in the gray zone. But in this study, they say it would have passed more likely into this zone, these waters here, before making it to Reunion Island. And they can tell this by analyzing the barnacles because they typically grow within a certain water temperature, 24.4 plus or minus zero point 0.3 degrees, or warmer waters. But they do not tend to colonize in colder waters. So this is why this study is important, because it basically tells us that the flaperon piece most likely originated in waters above 20 south, in these warmer waters. There's no way it could have originated from down here and made it to that way and not have any it would not have had any colonization of barnacles. So from this science, we know that the flaperon had to have passed through these waters on its way to Reunion, and very likely it came from this area up here rather than this area down here. And there's a couple of studies done on this. This study was done on samples that were only 6 months old, but the French BEA have samples that are 14-month-old, which indicates that the flaperon was in the water for at least 14 months. That really eliminates the possibility of anyone planting it, for sure. So once you understand the importance of this study here, these barnacle studies, you'll see that it's very unlikely that the piece would have originated from the southern Indian Ocean. It would have had to have originated from up here, based on these studies. Okay. Now, this is a buoy data, drift buoy data from Reunion Island. And as you can see from this historical data, most of the buoys that drift into Reunion Island come from this area here. You don't see too many coming from over here. They're all coming from this area up here. So again, this data here contradicts the official story. Now here's a buoy that drifted from July 2014 all the way to, I believe this is in Tanzania. Yes, and this is where the flat piece was found in Tanzania, same location. And this is how this buoy drifted during that time period, 14 months to get from here to here. This is how I suspect the debris from my crash location drifted towards Africa. and it would have drifted through these warmer waters down here on its way to Reunion Island, which would make it pass through waters that would be of the right temperature for colonization of the barnacles. So it's my belief that what happened was for the first 2 months, the debris started off in this waters here, which was very tropical waters, and drifted south to cooler waters. Once it reached cooler waters after about 2 months, that's where it started to drift into this area down here, I believe, into Reunion Island through waters that were more uh, temp, uh, more suitable for barnacle colonization. So I think this is definitely where how the debris from this area passed through to Africa, down like this. And what I'm going to show you here is a drift model I did. Let me just pause it for a second. Yeah, so in this model, what I can do is I can step through the months. And after 8 months, you see 10 months, you start to see some debris possibility. 12 months, very little. 14, you start to see some possibility. But at 16 months, that's where you start to see possibility from this area. That's where the debris starts off in this area and takes 16 months to get there, which is perfectly consistent with the time of discovery of the Flopperon piece. And this is why Blaine Gibson found so many pieces, because he was in the right area at the right time. And that's why he was able to find all these debris pieces. He was in the right area. That's where all the pieces were going, highest probability area. So there's no mystery there. So it all comes down to this photograph, this satellite image, which tells us where the debris field was last spotted. MH370's debris field was last spotted here. And the wreckage is somewhere within this red box. I'm fairly certain, I would say I'm virtually certain of my opinion, and I'll be 100% certain of my opinion once you find me the debris that's in that area and confirm that it's from MH370. But from all the years of study and all the analysis of the data that I've looked at, I'm virtually certain MH370 is within the wreckage of MH370 is within that red box. And I cannot make anyone believe this. If you read my theory, you'll understand why the Inmarsat data is completely wrong, and why I believe the plane was crashed in this area. So this is why I think I'm right, but I'll let others decide that and make up their own mind. But I'm thoroughly convinced that this is where MH370 ended up, that the satellite imagery is correct, and that witness Raja, who saw a plane floating in the Andaman Sea, is also correct. I mean, you get three sets of data that line up like this. This is independent data which confirms, without any bias, that this is the area where the plane went down. You can do the study yourself. Hopefully we can get other oceanographers to look at this. But the whole purpose of my website is to try to convince an oceanographer to take my research seriously and go look for this debris off the coast of Sumatra. If we could find one of these pieces and identify it, I believe we can solve the mystery of MH370. That's my personal opinion. And I hope one day someone will go and investigate this. Anyways, I'm going to leave you here, leave you with this thought. This is where the plane is, the wreckage, somewhere in that area. And let's hope one day someone goes and looks for that wreckage and we find it. All right? Okay. I'll see you in the next video. Have a nice day.